Hello guys, so we are going to continue the discussion with respect to linear algebra. In this video, we are going to discuss about a very important topic which is called as scalars and vectors. So first of all, understand scalars or vectors are just not used in data science. There is a different definition and application specifically when we use in field like physics, in mathematics, also we use them. And the third one is as a computer science grad, right? Again, my main aim of this specific course will be to understand how or what is the application of scalar and vectors specifically with respect to data science. Okay, whether you're working as a data scientist, data analyst, we'll try to understand the definitions. We'll try to see multiple examples of any topics that we probably discuss in linear algebra related to computer science and specifically data science itself. Why the reason data science? We'll consider use cases related to data science and then we'll try to understand. Okay, so let us go ahead and first of all understand about what exactly is scalar. Okay, so first of all we'll go ahead and see the definition of scalar. So here a scalar is a single numerical value, okay, and it represents a magnitude and it represents a magnitude or quantity and has no directions. I hope many people have probably seen this particular definition. Okay, a scalar is a single numerical value. It represents some magnitude or quantity and has no direction. Let me take some very good examples so that you'll be able to understand. Let's say I will go ahead and say about car speed. Let's say the car speed is somewhere around 45 kilometers per hour. The value 45 kilometers per hour is specifically the magnitude. Okay, and in scalar you do not have any direction. Okay, what is the difference between direction and magnitude? I'll just talk about it in some time, but right now you can just consider that a scalar is just a single numerical value. Okay, another example that you can probably consider, let's say I will go ahead and write temperature in Celsius. Let's say the T value is nothing but it is 25 degree Celsius. So here also we have specifically magnitude. Okay, so how does this see when we talk about this car speed, temperature in Celsius, right? These are mostly in terms of physics or anything like a normal. We are not specifically discussing with respect to data science. So I would also like to give you some of the applications of scalar specifically in data science. So let us go ahead and write application in data science. Now, as I said, scalar represents a single numerical value, So let's say if I have a data set, in this particular data set, let's say, let's consider that I have a feature F1, F2, F3, right? The F1 feature may be something else, F2, F3 may be something else. So in a data set, we will be having many records, Let's say there are 10 specific records, okay, or in this particular case, let's say there are 5 records, okay. Now, when I say with respect to scalar, right, as I said, it is a single numerical value. Let's say that I go ahead and calculate the count of the total number of records. So in this case, when I'm counting the total number of records, I'm able to get the value as 5, right? Similarly, if I go ahead and say, hey, what is the average of the feature F1, right? Let's say F1 feature is nothing but age. If I go ahead and calculate the average of all the specific records, I may get some kind of value, right? So this actually becomes a scalar quantity, right? One of the best example that we can probably consider, we use for a problem of regression, right? So there is a machine learning algorithm related to regression which is called as simple linear regression. Okay. So let me just go ahead and take this specific algorithm, simple linear regression. So in simple linear regression, you will be seeing that we use an equation which is called as y is equal to mx plus c. Okay. Now in this m is basically a slope, right? And in the c is specifically a intercept. Okay. Over here, we will not consider m as a scalar. Why? I will tell about it. Okay. But we can consider this intercept as a scalar value, right? So why this is basically just considered, the c is considered as an intercept. The reason is that it is a single numerical value. The m value over here depends actually on this particular data points, right? We will talk more about this, because this kind of data points of x, this is basically a vector data point. We'll discuss about what exactly is a vector data point. But if you just think of scalar, right? Here it is more like we are just talking about a single numerical value. It just has magnitude. It does not have any direction. Okay. So this was the entire definition of scalar and some of the applications that we have specifically used related to data science, and we have discussed about that. Now let us go ahead and discuss about vectors. So if I talk about vectors, okay. Vector, okay. First of all, we will just talk about something about vectors, okay. Again, this can be a numerical value which has both magnitude and direction. Again, this definition that you're seeing, it is with respect to physics, Here we are saying that, hey, it is a numerical value which has magnitude and direction. But if I probably create, or if I write a definition related to data science, here I can go ahead and write a vector is an ordered list of numbers. Ordered list of numbers. It can represent a point. It can represent a point in space or quantity with both magnitude and direction. Now let's talk about this. Okay. This is a really important definition. I've given two types of definition. One is in terms of physics. One is in terms of data science. First of all, we'll take an example with respect to the first definition. Numerical value, it is a numerical value which has both magnitude and direction. Let us consider one example which we have earlier taken, The speed of the car is 45 kilometers per hour and is moving towards east. Moving towards east direction. East direction. Now here you can see clearly that perfectly. I know that my car is moving in the east direction and the speed is 45 kilometers per hour, right? So we have this wherein we are representing the speed of the car with both magnitude and direction, where specifically we are going. We are going towards the east side. Okay. This is the basic definition or basic example we can probably consider in terms of the first definition that we have. Now let's go ahead and discuss with respect to the second definition, because that will be our focus point. A vector is an ordered list of numbers. It can represent a point in space or quantity with both magnitude and direction. Let me just consider one example. Let's say that I have an example over here. Okay. One of the most common, probably this can actually be used by anyone. I've given you an example with respect to house price prediction. Let's consider this example over here with respect to student marks. Okay. Let's say I have a feature which basically talks about IQ. Second feature is number of study hours. And third feature is nothing but pass or fail. So here I have three features. One is IQ, one is number of study hours, and whether the person is passing or failing. Let's say if the IQ is 90, if the person is studying for 3 hours, let's say the person fails. Okay, so this is my output. If the person is having 100 IQ, if the person is studying for 3 hours, the person will pass. So this is what is the data set it looks like. Okay, now let's consider every record over here, and let's just consider this two features. Okay, IQ and number of study hours. IQ and number of study hours. Okay, now here if I consider this as an example, so I can say a vector representing person IQ and number of study hours. So here if I just take the first record, here I can actually see that I will be able to show this in the form of vectors where my value is 90,3. Okay, 90,3. 3 basically means 3 hours. Okay, we can remove this unit. Now understand one thing, when I write 3 hours, right, 3 is the magnitude, hours is the unit, how this magnitude is basically represented by. Okay, understand one, this is really important to understand. This 3 is basically the magnitude and hours is the unit how this magnitude is basically displayed. Again, with respect to different scalar values, this unit may change. Okay, it may not be same for everyone. So in this scenario, I have a vector representing person IQ and number of study hours. Okay, let's say I even have one more kind of data. Okay, so let's say that I have something like the example that I can take, a vector representing person weights over time. Okay, let's say in the first year the person was weighing somewhere around 70 kg, or in the first month, let's say in January month. In February month the person is weighing 72. In March month the person is weighing 75, and in April month the person is weighing 73. So this also represents a vectors with respect to time, right? So this was for Jan, Feb, March, April. Okay, now see, many people may be thinking, Krish, where does direction come into picture? See, in context of data science, whenever we talk about vectors, we don't necessarily mean that they have a physical direction in space, like how a vector basically has, right? In physics, if I probably say there is a concept called as velocity, right? If I represent a vector in data science, it represents a collection of values. Okay, collection of values like this. It can be in different dimensions. Right now, since I have this vector of 4 values, this basically represents a 4 dimensions. Okay, so literally you don't need to even think like, hey, does this have a specific direction in search, right? Let's say if I just represent with respect to physics. Okay, let's say I have a vector which is called as x, and this vector is represented by 2 dimensions. Let's say the value is 1, 2. Now, in order to see this vector, specifically in physics, what we do, we create a coordinate system. Okay, so we basically define a coordinate system. So this is my coordinate system over here. This is my x-axis. This is my y-axis, right? In the x-axis, I have values like 1, 2, 3, 4, 5. In this side, we basically, these values will become negative, -1, -2, -3, -4. Similarly, if I probably consider y, here on the top, it will become positive 1, 2, 3, 4, right? If we go below, it becomes negative -1, -2, -3, -4. Now let's see this. If I say, hey, this A is my vector, let's rename this to A, because you should not get confused with this x and y. Since we are using this as 2 dimensions, 2 dimension basically means I will be having 2 different values over here, right? If I just have one value, that becomes 1 dimension. In 1 dimension, we just create a plane, straight line, and we can just let's say if this is 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, we can just go ahead and populate this point over here, right? Any points over here, whatever points we specifically have. But here we are discussing with respect to 2 dimensions. So I have 2 coordinates. Let's the first coordinate be denoted by x and the second coordinate be denoted by y. Now in this scenario, when I say 1, 2, 1 is basically my x coordinate. So this is 1, right? And if I probably take 2, so 2 is my y coordinate. So it is somewhere here. Where does this 2 point meet? It meets over here. So this specific point is represented by 1, 2, right? And again, in order to calculate the distance between this origin and this vector, it is very simple. Why it is very simple? Because you can directly go ahead and apply your Pythagoras theorem. How does Pythagoras theorem apply? You can probably take this value. This value is nothing but 1. This value is nothing but 2, right? So when you have this 1 and 2, right? So according to Pythagoras theorem, in order to calculate the hypotenuse, you just take this adjacent side, right? Let's say that this is my OAB point. So it is nothing but OA square plus AB square, right? This is how you basically calculate the hypotenuse, right? So what is OA square? OA square is nothing but 1 plus 4. This is nothing but root of 5. So this distance OB is nothing but root of 5. So if somebody asks you what is the distance of this particular vector from the origin, it is nothing but OB, right? And this is how you represent this specific point in 2 dimensions. So when we say 1, 2 with respect to this x and y, that basically means, hey, first of all, we are moving 1 unit towards the x-axis and 2 units towards the y-axis. This is what this entire vector represent. Okay. Similarly, let us go ahead and take another point. Let's say this is my b, and here we are representing the vector by minus 3, and let's say this is also 2. Now in this scenario, the point that we are going to probably specify in this coordinates space, so we'll move towards the x-axis, that is minus 3, 1, 2, 3. So this is the point that will specifically go, and 2 is somewhere over here, right? So over here, you'll be able to see this will be my vector, which will be represented by minus 3, 2, right? And here is what we are basically going to get this direction, right? And this can be defined as OB, right? And we can also calculate the hypotenuse. And this is the direction of this vector. This is the direction of this vector. Now, these are some very important things. Now, similarly, if you go ahead and probably even see for 3 dimensions, let's say there is a C vector which is represented by minus 4, or it is represented by X, Y, Z. Okay. Now, in this case, I definitely require a 3-dimension vector. So let's say this is my X coordinate, Y coordinate, and Z coordinate. So if I just go ahead and consider this X, Y, Z, right? So in this particular coordinate, we may have one point which will be denoted by X, Y, Z, right? X, Y, Z. So this basically is 3-dimension. Obviously, it is not possible to see the 4 dimensions. So here you can actually see for this particular coordinate, or for this data point, we can represent it as X, Y, Z. Now, let's take one very good example to understand how these vectors are specifically related to data science. Okay. See, in machine learning, in deep learning, what we specifically do is that we create a models, right? We create some kind of models. This model, some models are black box. The main aim of this specific model is to probably take input data, right? Input data can be F1, F2 feature, and it should be able to predict my output feature, right? This output is nothing but the response of the specific model. Let's consider an example. Let's say that I have the same data set over here. Let's say I have this data set. Okay. I have this data set. Or let me write it down. Okay. If I probably consider this data set over here, IQ, number of hours, and I have data points like pass or fail. Okay. Let's say here I have 90, here I am probably studying for 2 hours, so the answer is fail. This fail can be categorized as 0. Okay, similarly, if I have 100 IQ, if I study for 2 hours, I will be passing, right? And this can be also categorized as 1. So if we consider this kind of data points, you'll also be seeing that since I have this feature 1 and feature 2, and this is my output feature, these are my independent feature or my input feature, and this is my output feature or dependent feature. So when we give F1 and F2, let's say that we have a huge data set of 10,000 records. Then we can train this specific model. Again, for training this particular model, we can apply different algorithms like simple linear regression. Since this is a classification problem, I can go ahead and apply logistic regression, and different types of models, algorithms will be present. But the main aim is just to understand about the vectors. Each record, I can represent it as a vector, each record. So if you probably go ahead and see this, if I just go ahead and plot this point will be plotted with respect to IQ and number of hours. Let's say my IQ values are from 80, 90, 100, let's say 110. Here number of hours can be 1, 2, 3, 4. Now if I want to plot 90, 2, right? 90 is in my x-axis. So I will probably go towards x-axis over here. And 2 is coming over here, right? In the y-axis. So I will move over here. So this point is basically nothing but it is a coordinate of 90, 2. And again, in order to calculate, and this is my vector, it will move in this specific direction. Similarly, I may have my another record, 100, 2, right? 100, 2. So 100, 2 is nothing but here again, it will be going over here, and this point can be represented by 100, 2. Or let me just do one thing. Let me go ahead and write 100, 3. Okay, so that the points will not overlap. So here now, if I go ahead and just convert this 2 to 3, so 100, 3 will be this point, right? And here I will be going to write this coordinate as 100, 3. Now the difference between these 2 points is that this I have marked as yellow and this I have marked as red. Why? Because red, let's consider red is specifying pass, yellow is specifying fail. So that is the reason I have used 2 different colors. So at the end of the day, for every records, we can represent it in the form of vectors. Because at the end of the day, you'll be seeing that how I will be solving this problem. This problem will be solved in this way. Let's say I have some of the coordinates over here, which is displayed in this color, white color. White color represents pass, okay, or fail, sorry. And let's say pink color represents pass data points. Now what we do while probably training a model which will be able to classify these points, it will try to create a linear line between them. Okay. Whatever is coming, any new data point that comes below this linear point, right? It will predict that the person has passed. So this region, sorry, it is nothing but fail, and this region is nothing but pass. So let's say if I get a new data point, if it comes over here, it goes and sees, hey, whether it is below this particular line. This line can be represented by a linear equation, y is equal to mx plus c, right? If it comes below this particular line, right, then it is going to treat that, okay, this data point will probably fail if a person with this data point specifically comes, right? Similarly, if a new data point comes over here, it is above this particular line, right, best fit line. So here this coordinate will specify that my outcome will be pass, right? So that is how we basically do the classification. But the main idea over here is that every data point in our data set is specifically represented in the form of vectors. Okay. Now there may be many scenarios that I may also have other features like F3, F4, F5 feature. Now in this kind of case, right, max to max with our human eyes, we can actually see only 3 features. But linear algebra is so amazing that since it supports a lot of matrix calculation and all, any number of features that may be there, right, it will be able to represent that specific dimension, right? Like if I go ahead with this 5 dimensions, a single point can also be represented in 5 dimensions because it has 5 different points. But just to make you understand, I have shown you with respect to 2 dimensions and 3 dimensions. So this was about vectors. Okay. Some more examples if you really want to see with respect to vectors. Okay. One very important property about vectors is that let's say that I have a vector over here. Okay. I have a vector. Let's say this is my x and this is my y. There's a concept of something called as unit vector. Let's say this is value like 1, 2, 3, 4, and this is also 1, 2, 3. Okay. Let's consider a data point. Let's consider a vector with 3, 3. Okay. 3, 3 is this specific vector. Okay. That basically means we are moving three units towards the x-axis and 3 units towards the y-axis. That is what we are specifically doing. Now, there is a concept of something called as unit vector. What does unit vector mean is that an unit vector is represented by this symbol. Okay. This symbol. Okay. If I write v as a vector, we usually use a cap. Or let's consider u as a vector, we use it as cap. This unit vector has a magnitude of value 1. Okay. That basically means if I consider this, okay, if I consider this is my unit vector towards x-axis, if this is represented by I hat, okay, and this is my j vector, okay, this is my, let's say, j vector towards the y-axis. This is the unit vector towards the y-axis. Now, if I say 3 unit vectors towards the x-axis, that basically means I'm moving 3 times, right, of that of a unit vectors, like 1, 2, 3. Similarly, if I say 3 unit vectors towards y, I'm moving 3 position towards the y-axis. The unit vector value is 1. So this entire vector can also be represented as 3i plus 3j, right? This I and j are specifically, these are nothing but unit vectors towards x and y-axis. X and y-axis. What is the importance of this unit vector? We'll talk about it. But in short, this magnitude value is equal to 1. Okay. I will talk more about the unit vectors and why it is important. But I really wanted to show you this representation. 3i bar, that is 3 unit vector of I plus 3 unit vector of j, right? So if we specifically use this, because why we are doing the addition? Because we are moving 3 vectors towards the right, and then we are adding another 3 vectors towards the y-axis, right, which is represented by j. So that is the reason we are representing in this way. See, we are moving 1 position, 2 position, 3 position towards the right. Then we are moving 3 position towards the y-axis. So that is the reason it is represented as in this way. Okay. Let me talk about some of the very good examples that are there, and we probably use it every day. Okay. Specifically in gaming industry. In gaming industry, vectors are specifically used a lot. I hope everybody has played this game of GTA, right? And GTA 6 is probably crazy thing, right? Which people are waiting for this particular game. But if you have played GTA 4, GTA 5, right? You'll be able to see that, let's say, and I hope you have driven some amazing cars over here because you get every cars. Let's say that I take a Lamborghini and I'm driving at this specific direction. Okay. I'm taking a Lamborghini. I'm driving at a specific direction, let's say with 200 kilometers per hour. Okay. And again, there's a police car that is probably coming from here. So there's a police car, and I hope you have seen this scenario also, which is coming from here. Let's say this is the direction and it's coming at 100 kilometers per hour. Now, you know that when this specifically collides, right? Because see, at the end of the day, the speed at which we are coming and the direction at which we are coming, right? This can actually be represented in the form of vectors. This can also be represented in the form of vectors. But once it does collide, right, there will be a lot of adverse effects. Adverse effects. What kind of effects? The car will get blown up, right? Get blown up. It'll catch fire. It'll rotate 100 times and it'll fall in some kind of building or anywhere, right? So this kind of adverse effect or outcomes, it is derived from this particular vectors, and these are the units that are responsible over there. Just imagine that you're writing condition, hey, when a car of 100 kilometers per hour or probably 200 kilometers per hour is colliding, some or the other effect should happen, and that kind of animation gets changes over there. I hope you have also probably read in, like let's say in GTA, you will be having an option to ride the boat also. Now, when you are riding the boat, you specifically ride in the waves, right? This waves will be moving from one direction to the other direction. Let's say the vector is representing this particular direction. It moves towards 60 kilometers per hour. Now, if you're coming opposite of this particular wave, then what will happen? Your boat will be jumping high, right? So you can actually see what is the adverse effect from if the vector is coming over here and if your boat is coming from this direction, right? It will keep on jumping. How basically this is derived. Here also, a lot of vector spaces, coordinate systems are also used. The impact that is probably created, you specifically do a lot of coding with respect to each and every scenarios that you probably check, right? So I just wanted to talk about more examples over here, and that is the reason why I've actually spoken over here. But I hope you are getting an idea like why it is really important to probably understand about vectors and what all additional things that you'll be able to see. Okay. Now let me explain one final thing before I probably move towards the next topic, and in the next topic we will see what is vector addition, then what is vector multiplication, and what exactly it means with respect to that coordinate system. Let's say that I have a small box over here. Okay. Let's say this box is moved by two people. Okay. So one people is over here, one person is over here. So this person is carrying from here, this person is carrying from here. We need to move this box. So this box is right now in a different vector space. Let's say it is in over here. Now this needs to be moved towards this particular point, right, in this coordinate system. Now, one thing, if we really need to move, then what will happen? First of all, these two people will carry. It will go towards this point, right? And then both these people will carry towards this point, right? So that is how we will probably reach our final point, right? So let's say if this was 0, 0, right? Then we need to move towards 3, 3. So what we did, we moved 3 position towards the right and 3 position towards the up in this direction. So this is my vector direction, right? Imagine the person also moving, right? The person will probably also move like this and they'll go up, right? At the end of the day, if you see, the person will also be moving in this direction, right? This will be the person new direction, and this person will also be moving in this direction. Just by seeing these 3 vectors, right? What is the difference? Only the origin point is changing, right? But the direction of this particular vector is same. The length of this particular vector is same, and it is moving towards the same direction. Similarly, in coordinate system, if this is the origin, and if I have a coordinate, that vector may move in this direction also. If my origin is something different, then with respect to the same coordinate, it will move in it will also move in the same direction. Only the origin point will be different, right? And this can happen in any part of the coordinate system. It will be in the same direction and the length will also be same. That is what I really wanted to specify over here, right? So please remember this specific property of vectors, right? This will be very much important for you all to understand, right? So I hope you are able to understand about this specific video, and I was able to explain you with respect to these things, right? If I talk about vectors, it will be very, very much handy. We will be using, with respect to any data set, we'll be representing each and every data points in the terms of, in the form of vectors, specifically in a space. Now, the vector can be 2 dimension, 3 dimension. It can even be 5,000 dimension. No worries, right? Because we will be seeing how we can convert back the higher dimension into lower dimension. But in this video, we've spoken about scalars and vectors, and we have got an idea about it. So in the next video, we'll be having more discussion about vectors. This was it from my side. I'll see you in the next video. Thank you.